Okay, so we're another competitive exam here. There's 5 questions. Looking through it, low hanging fruit. I'm gonna say 1 looks like it's manageable, but it looks like it'd be some work over there. 2 looks like it's manageable, but there's some work over there. 3 looks easy. 4 looks easy. 5 looks easy. Let's do 1 at a time. I'm gonna do 3 first. It says solve for A. And how would you do that? Well, just going back to some basic algebra. Your teacher's probably told you to isolate the radical. I'll put this down for you. Square both sides. It's a quadratic, so I use quadratic equation or the zero product rule. A squared minus A minus 6 equals 0. Let's try to factor it, A and A. And then you'd get what? 3 and 2, right? And that's going to be minus 3 plus 2. Let's see if that works. A squared minus 3 plus 2 is minus A. Yeah, it works. What do you get for the answers? You get A equals minus 2 and A equals 3. And you should understand that when you square both sides, you may have introduced what's called an extraneous solution. So I'm going to check them. I'm going to check this one and check this one before I box any answers on this one. Then we'll look at the key. Let's try minus 2 first. If A is minus 2, I'm checking in the original. You would get minus 2 plus. Well, see, 6 plus minus 2 is going to be 4. That's root 4. And that does, in fact, equal 0 because minus 2, the root of 4 is 2. That does equal 0. So this certainly satisfies the equation. All right. Let's try the other one. Let's see if that gives you. What do you get there? 3 plus the square root of, well, 6 plus 3 is 9. Does that equal 0? No way. You get 3 plus 3. That does not equal 0. So this is not good. There's only one answer over here. The answer for number 3 is A equals minus 2. That's a very low-hanging piece of fruit. I'll go to the key in a moment. I want to do 4. And it looks like a simple problem for me. And it's a log problem, and they want to find a value of this. So it's log base 4 of 8 squared, which is 64, minus log base A of 1. Well, again, it looks like really low-hanging fruit because, 4 what power gives you 64? That would be 3. 4 cubed is 64. 4 times 4 is 16. 4 times 16 is 64. Minus, well, A raised to the power 0 is going to be 1. So this would be 0. So what do you get over there? 3. All right. Let me do number 5. Again, I believe it's low-hanging fruit. What is 5? Kx squared plus 5x. I'll write this down for you. We'll look at the key later, by the way. So I'm doing number 5 now. So 4, this is 4 over here. And we did 3, and now we're on number 5. So kx squared plus 5x equals 10k. What do they say? They say in the equation, find the other root if one of the roots is minus 5. Well, this thing has 2 roots. And they're giving me 1 root, but they give me minus 5. So what do you get? 25k. That means x equals minus 5, by the way. Let's see, 25k. I forgot to put the k in there. And what do you get over here? You get minus 25, and that would be 10k. Well, let's see if we can solve that. I'm going to get 15k. I'm subtracting 10k from both sides is 25, and k equals 25 fifteenths. And what do you get there? Well, I'm going to reduce that. That would give you 5 thirds. So I know my equation now. My equation is going to be 5 thirds x squared plus 5x equals 10 times 5 thirds, which is 50 thirds. Now, I don't like the fraction. What I'm going to do is I'm going to multiply both sides by 3. All right, let me write that down for you. And what do you get there? You get 5x squared plus 15x equals 50. The next thing I'm going to do is I'm going to divide both sides by 5. That's like multiplying by 1/5, by the way. And what do you get? X squared plus 3x equals 10. And lo and behold, this is going to be pretty easy to deal with. Whoops, maybe I shouldn't go so quick with that. I'm going to use the zero product rule. I'm going to get a 0 first. How do you do that? X squared plus 3x minus 10 equals 0. By the way, I know one of the roots is x equals minus 5, so this would be x plus 5, and then you get x minus 2 over here. Let's see if that works out. Yeah, it does. So what's our question again? in the equation, find the other root. The other root's going to be x equals 2. All right, let's go quick over this. And again, those last three were pretty easy. I think you probably remember we did this one over here. It does say the other root's extraneous. We did this one over here, and we just did this one over here. So those questions are definitely easy. So let's go to the other questions, and the other questions are more difficult. All right? So looking at it, number one, I want to just remind you, this has something to do with the geometric. I'll write this down. And the geometric is going to be, let's see, n equals 0, r to the n. This goes off to infinity. This would be r to the 0 plus r1 plus r2 plus yada yada. And that's got a nice easy sum to it. And that sum can be 1 over 1 minus r, provided the r is a proper fraction. So I'm going to say this one sort of looks like that, but really not the same. So I just want to remind myself that, you might play around with it a little bit, but I just want to, go through some work over here. So I'm going to get my eraser out, but I know it has something to do with the geometric. I'm going to erase this business over here. I really don't need it. All right, you could use it, though. I'm not saying you can't use it. So what I want to do is I want to write down, the sum. And I'll go through what your teachers probably told you in, your pre-calculus class or algebra class. I can write down S infinity for this one. So this is S infinity. And what's that going to equal to? Well, it's going to equal to, it's written down for me, 1 over n plus 1 plus 1 over n plus 1 squared plus yada, yada, yada. You know what? Let's do Sn now. All right? This is the nth partial sum. And then what I get plus yada, 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 well, I'm going to be stopping at n, so what do you get? 1 over n plus 1. And if we're stopping at n, this would be n over here. Now what I'm going to do is I'm going to multiply both sides by n plus 1 now. And what would you get? You get 1 plus 1 over n plus 1 plus 1 over n plus 1 squared plus yada, 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 all up to 1 over n plus 1 n minus 1. I'm going to subtract. Let's write this down for you. Sn minus n plus 1 Sn. And if you subtract those, you get something that's fairly simple. And I want to point out what I mean by that. A lot of things will disappear. Let me get my red pen out. So this would disappear if I subtract it. This would certainly disappear. And, the one before this would make that one disappear. So what are you left off with? And let's write this down. You'd be left off with, whoops, let's go back to black ink. You'd be left off with 1 over n plus 1 to the nth power minus 1. All right? Now, yeah, I got some work to do. I can get my eraser out and erase this other business over here. This is old stuff. Again, we're just quickly going through this. And I'm going to basically see if I can do that sum now. And what do you get? Sn, it's the nth partial sum. And that would be 1 minus, again, I'm doing this part over here, just factor it in Sn, 1 minus n minus 1. Gee, that's not so bad. And what do you get over here? Well, let's write this down and be careful about it too. It's going to be n plus 1 to the nth power. And then you would get 1 minus n plus 1 to the nth power. All right, well, what's nice about this is this thing really simplifies just to minus n. So I'm going to write Sn down. And I'm going to divide both sides by minus n now. And you get this over here. And I'm dividing by minus n, so it's n plus 1, n minus 1. All right? So, oh boy, I got some troubles here, don't I? Let's keep doing this. Sn. I'm going to divide top and bottom by n plus 1 to the nth power. So this would be 1 minus 1 over n plus 1 to the nth power. And the bottom would just be n. And let's take a look. That limit looks too tough to do. So you know what? I'm going to go back to the geometric. And I'm going to point out, maybe I made a mistake. It does happen sometimes, you make a mistake, but you got to be quick on it. I'm not going to say I'm at a dead end, but I'm at something that it looks too much work for me to do. So I'm going to go back over here. And I want to go back to that geometric I did in the beginning. Probably should have kept that. All right, so what is this going to be? It's going to be this over here. N equals 0 to infinity. Rn is 1 plus, well, it's going to be 1 plus r squared plus yada, 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 up to Rn. And that equals 1 over 1 minus r. All right? So I was hoping to get something simple like that for this one over here, too. And I'm not saying I couldn't. It just seems like it was doing too much work. But I got troubles over here, and I'll tell you what the troubles are over here. You know, looking at this thing over here, it really doesn't look entirely like this one over here. So what I'm going to do is I'm going to try to write it down so it looks like that. So I'm going to put down, you know, minus 1 plus 1 plus 1 over n plus 1 squared. I want to get it to look like this over here. So I'm looking at this now. Plus 1 over n plus 1. Let's see, 1, 2. Whoops, I'm sorry, I made a mistake already. That's a 1. This is a 2. And I'm going to say yada, 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 yada. All right? So what do I got? I got minus 1 plus, well, I'm going to use my formula now. And this is the form we're going to use. And what's the R in this problem? It's just 1 over n. So we get 1, and then you get 1 minus 1 over n plus 1. All right, let's keep moving. And again, there's conditions on this. I'll do those conditions later. Maybe I should write that down over here. So the R in this problem over here is 1 over n plus 1. And the absolute value of that, I should write this over here, the absolute value of R has to be, it has to be a proper fraction. So the absolute value of this thing also has to be a proper fraction too. Let's see if we can do that. And the sum, minus 1 plus, well, that would be n plus 1 minus 1. I'm multiplying top mod by n plus 1, and then n plus 1. And what do you go there? Minus 1 plus n plus 1 over n. Boy, this is convenient, isn't it? And let's keep moving. And I'm going to just write the answer down now. So what's going to be? Calm down, it's going to be n. And what do you get up there? Minus n plus 1, which is 1 over n. So this thing's remarkable. It turns out to be 1 over n. But the condition, all right, is going to be this. I need this condition. So I need to find out when this happens. And this would happen when the absolute value of n plus 1 is greater than 1. I'm looking at this inequality over here. How do I do that? Well, n plus 1 could be greater than 1, or the n plus 1 would be less than minus 1. And that's pretty easy to solve. So n is greater than 0. That's that one over there. And this one over here is n is less than minus 2. So I'm going to claim this sum over here. The sum is 1 over n. That's what the sum is. And the conditions placed on it is the n must be less than minus 2, or the n has to be greater than 0. So that's what the sum equals. This is the condition on it. All right, so let's take a look and see if we got that. I see this over here, and I see this condition over here. Again, remember what I did in the beginning. I wrote down this thing over here, and then I failed to use it. I probably should have used that immediately, because then what happens, I start doing work on it, and I start to realize that it was too much work. And that's why I went backwards. All right, number 2, let's go to number 2 now. And let me go. I'm actually going to go to the notes over here. And I'll write this down over here, one step at a time. So they give me this condition here. I'll write down what this says to me. This says A divided by B is equal to B divided by C. And I'm going to rewrite that a little differently because I don't like the fraction. I'm going to write it as AC equals B squared. And again, this may not be helpful, but I like to get rid of the fraction. Now, the next thing they ask me about is they say express this with only one of the letters. So the claim is that this could be written either in A, B, or C, but only one letter. So what I would recommend you do is, kind of simplify it right from the get-go. And what do you get? A squared minus b squared plus c squared. That's three different letters, by the way. This is 1 over b squared minus 1 over a squared minus 1 over c squared. I would get rid of the complex fraction by multiplying by the minor LCD, which is a squared, b squared, c squared, a squared, b squared, c squared. And what would that give you? Let's be very careful about this. You're going to get a squared, b squared, c squared. Again, I'm just simplifying so I don't have negative powers. And then you're going to get a squared plus b squared plus c squared. On bottom, what do you get? Well, let's see. You get a squared, c squared, minus, well, the next side is going to be b squared, c squared. And the next side is going to be what? A squared, b squared. All right, I'm looking around for things to do. And I want to point out, this is one thing I want to do. Right, so I'm going to say b squared is ac. All right, let me see if I can do that. So what do you get over here? You get a squared, and b squared is ac, right? Times c squared. I just did, let me show you what I just did. I just did this part here. I'm going to get my highlighter out. Sorry about that. I just did this. So that's what that is right there. Now what I'm going to do is I'm going to go in the parentheses now and see if I can get something to do with that. And, you know, when I got a squared, b squared, again, we're looking at this, is ac. And someone says, what are you doing over there? I'm just getting rid of one of the letters. I'm getting rid of the b in the problem. Again, this could be a dead end. Now, I'm looking at the a squared, c squared. I'll keep that. This is on the bottom now. Minus, well, what's the b squared? It's ac. So what do you get? ac times c squared. All right, I'm just doing the bottom now. Minus, well, let's see. What would you get? A squared, b squared. That's going to be a squared times, well, the b squared is just ac, right? All right, I'm got a little better. I'll tell you what I've accomplished. I've gotten rid of the b in the problem, but now I got all these ACs in the problem, and there's a lot of them. So I'm going to kind of simplify the top a little tiny bit. And what do you get? A cubed, right? C cubed. And then what do you get? You get a squared plus AC plus C squared. Now the bottom, I'm looking at the bottom. I'm going to factor out, I guess I could factor out like an A, C, right? And what would you come up with? Let's see if I can do that. And, oh boy, that's going to be tough, right? So you get AC. Oh, you know what? I copied something wrong. I just noticed it, and I got to correct it. Sorry about that. It's important when you do copy something wrong is go back over it and recopy the correct thing. And I just, for some reason, I didn't write that thing down. I don't know what happened there. Let's say I got AC, right? And what do you get next? You get C squared. That's going to be minus C squared. And then what do you get there? I factor out an AC, right? So what do you get over there? An AC. You just get A squared, right? Well, there's a little bit of a problem with this. So I'm going to start to reduce this. And what is it? I just get A squared, C squared on top. And this is A squared minus AC plus C squared. And I notice the bottom, I notice this guy over here, it's really not in the right order. So I'm going to factor out a minus 1 on that. And what are you left off with? A squared minus AC plus C squared. Now, what's nice about this is this cancels off. And what are you left off with? You're left off with minus A squared C squared. It certainly got simpler, but I still have two letters. And then the question is, what would that equal? Well, we've got it right up here. It's just simply minus B squared. I'm sorry. I'm sorry, b4. Sorry about that. Again, this is a squared b squared, which is going to be minus b4. Sorry about that. I'm seeing that right over here. Okay? So I think we did it all. I just want to go through this again with you. Easy problems, always look for low-hanging fruit. Get done with that. And that's what most competitive people are doing. They're looking for the lowest hanging fruit. And I want to just go through that again with you. I'm going to say sorry about that. Probably 3 is easy, 4 is easy for most students, 5 a little more complicated. I'm going to say 1 and 2 are probably the most difficult problems over there. But between 1 and 2, I would say 2 is easier than 1. All right? But again, you're trying to maximize the number of points you're getting. All right? I realize some students may have questions over here after me doing this. If you want to, you can reach out to me. My email address is Bannon. That's B as in boy, the @ symbol, NNON.US. So students and teachers, you can always reach out to me if you like. Use that email address. And please refer to what you're looking at. Like, for example, over here, tell me you're looking at this document, and you're in this section, and you're doing this problem over here. All right? Now, granted, some people say I have a better way of doing this. We're not suggesting otherwise. Post a video if you want to put another way of doing it down. And it can't hurt to have other people to look at that. All right? Thank you for paying attention, though.